All right, perfect. Great. So we have Ian Ray from Stretch2Go, and this is a fascial type of stretch. Yeah, can you tell us a little bit about what you do?
Yeah, so as a fascial stretch therapist through the Stretch2Win Institute, basically it's a table-based stretch therapy working on the fascial lines. And so the founders, Chris and Ann Frederick, came up with this as far as they've been doing this for 30 years. And so as a stretch therapist, I'm able to help those with chronic issues or those who have restrictions in their fascia on a massage table. And, we're assessing all the time. We're also figuring out where in the fascial lines that they're most restricted or holding tension and doing it through some stretch therapy. So has a lot with traction, a lot with oscillation, circumduction, but it's very pain-free and it's scientific based. So a lot of things that you're doing already, I was very interested in learning more because of the sports performance, because of the founder's background in sports performance, working with professional and Olympic athletes. I just felt like what you have to share can be beneficial for me, learning that fascia plays an important role in athletic performance and in your daily life. So yeah, I'm excited to be here.
Yeah, so fascia is the topic that was pretty much ignored in the mainstream, especially sports performance for a very long time. Um, well, because of the advance in, anatomy knowledges in fascia and imaging technology, and then also a lot of the research that showed, fascia is not a passive tissue. It can actually contract, and also a lot of different cells, like the myofibroblast cells, the fibroblast growth factors 1 and 2, are essential to healing and remodeling of the body. This become a hot topic in I think the last 5 years or so. And what we do is, number one, we try to answer a very fundamental question about, the fascia's ability within the body to compensate. So, for example, when people um, do weightlifting, when they try to squat, right?
Mm,
So I see some of your stretches also you have people do different type of squat, right? So that's one of the scientific question we try to understand is why do some people when they start to do squat with the weight on their body they start to compensate. So instead of using the glutes or hamstring on the core, they will start to use like quads and lower back. And then some of them also they have a rounded, it doesn't matter what technique you try to teach them, they tend to compensate and then they end up injuring themselves, even though the weight is not too much. So so this was one of the fundamental questions we tried to answer. And then we used a lot of for example EMG to understand why there is a difference in this type of pattern, right? So we took elite level athlete and also average people who seem to be a little more quad dominant, and then we measure how they squatting and how much of a neurological connection do they get into their body, right? Whether it's going to the glutes or to the quad in real time. So we had this EMG measuring device, a suit that we have them wear. So this is very interesting experiment. So the end result is that we started to see a pattern with the feet because the feet and how the feet influences the glutes through this fascial connection, which is continuous. And it's
yeah,
not through the muscle because there's no muscle that goes from the foot to the glutes. But there is a continuous fascial connection and tissue, which we've seen through fascial dissection, which I've done. So it's through this fascial connection by manipulating and also changing the structure of the foot and stimulating the foot in the right way, training the foot the right way, we can then change the pattern. So this is what hyperarch fascia training, one of the fundamental concepts and principles of hyperarch fascia training, is to change this foot to glutes connection. Now,
Mm-hmm.
everyone could be, any athlete could be situated anywhere along the spectrum of what we call a spectrum of athleticism. So on one end, you could have somebody who's very quad dominant, very muscle driven, and you have on the other side is more fascia driven, glutes dominant. Because in reality, from the fascia anatomy point of view, your glutes has 80% of the fascia lata coming down to the feet, which is very, very large. And if you remove this tissue just to reveal the gluteus maximus and gluteus medius muscle, its connection to the IT band through the tuberosity, that's only the 20% of it. So that is really, the biggest difference. Because if you're doing, for example, a hinge movement, let's say you're
Mm-hmm.
doing a hip bridge or a hip thrust, any type of movement you're doing, or even like uh, using a band on your around your ankle, you essentially just working that muscle in isolation, right? Because you're isolating, you're hinging. But when you actually playing sport, you're upright, right? You're running, you're upright. If you need to change direction, whether it's soccer, whether it's basketball, whether it's doing MMA, you're upright. So that means when you're when you're upright, your glutes have to activate properly. It has to it has to be activated, and then because of the tensegrity model, it and the pressure around the glutes should increase and then become the dominant force. Naturally, automatically, subconsciously, that should happen. But this type of behavior or dynamic doesn't happen in average people. It doesn't. But it happens with, for example, the champions or the Division One athlete. So the question becomes, how do we train this? Can this be trained? So that, for example, you're moving forward and back, you're hopping, the pressure and then the activation doesn't go to just your calves, but it can travel up the stream to the glutes and core. And over the course of 10 years, we found that it's possible to train. So this is also why, we helped produce two very high level world champions, one in decathlon and one in the UFC.
I have a question for you. Starting all of this, what made you start getting into fascia? Like, what was your beginning into the fascia realm, and like, how did you come up with Hyperarch fascia training? Because it's very specific, very niche, but
Yeah.
kind of short.
Yeah, I mean, in the beginning, when we started, of course, we also, as performance coaching, we started with weights. But
Mm-hmm.
what we realize is a lot of the top level athlete or athletic individuals, they don't follow the the mainstream understanding of big muscles. They don't have big muscles, and they're lanky. They could be on the skinny side, but they're very athletic.
Mm-hmm.
And and what I found out is over time is that you can have somebody who's very strong in the gym, but they still can perform on the field. So there's a disconnect, right? So then we're like the fundamental question is we realize that the people that are very strong in the gym versus the people who are very good in the field, they have different neurological patterns. So for example, I send a EMG suit to Cardoziani, one of the highest um, leapers in the world at his prime. He had like a 50-inch vertical single leg, and he never lifted weights, and he
Mm-hmm.
grew up barefooted, in France. He never lifted weights, and he had this incredible natural athleticism. So how is that even possible, right? So it's that. So if you're saying, okay, to build athleticism, you need to lift weights, then there's something clearly missing, right? So that's how we started to look into this direction. Now, before, when we started this work, we didn't know too much about fascia. But then when we started to understand, okay, there is a foot to glutes connection that we have to establish. What is that medium? That medium is your fascia.
Mm-hmm.
Because there's no muscle, no single piece of muscle that goes from the foot all the way to the glutes. It's just not possible. So then once we understand more about the fascia, we understand its properties, we understand what's going on really. Because your fascia is has these properties called mechanotransduction. So it's taking in tension and stimulation into or mechanical tension and change that into electrical and chemical signals. So previously, a lot of the mainstream old school coaches, they're like, oh, everything's neuromuscular, right? But there's no neural if you don't understand the fascia, because the fascia is that enabler, is that medium.
Mm-hmm.
You can't even get to the nerves if there's no proper fascia function. So let's say the fascia has a problem, dysfunction, right? The mechanotransduction doesn't happen correctly. Then your nerve don't get stimulated. So it doesn't matter what you're doing, really. The fascia has to be trained first. So
Yeah.
that's how we started to understand the fundamental relationships between the human anatomy and also all the tissue supposed to work. And this is also why for us humans we have very large plantar fascia. Like if you look at any other animals, right? So they have for example, there's animal that have hoofs, there's animal that have claws, right? But for us, we somehow we have this very big piece of plantar fascia underneath that need to sense different elements of the floor. If you look at nature, there's many, prickly things in nature, right? But your foot is supposed to be able to adapt to those type of stimulation and then calculate how much force is needed to engage your fascia, which then co-contracts your muscles in an
Mm-hmm.
effortless manner. But that's very different than the mainstream way of understanding because if you're lifting weights, you are essentially saying, okay, all your muscles have to be tense.
Yeah.
You cannot move your arms and freely. You cannot move your limbs freely because there's a lot of weight stacked on you, right? But if you look at the movement of high level athlete when they run, when they jump, when they leap around, even for a basketball player in the air, they're doing like double palms and windmills. They're still free to move their arms. So if you're telling me that the muscle is what enables them, then those things cannot happen. So what is really happening is that your fascia is supposed to activate and co-contract everything, but your muscle remain relaxed, so you can able to still do movement while, for example, you're in the air.
Mm.
So that's a completely different understanding. And also the when we measure for example, the stiffness, we use the Milton tools to measure the stiffness. If the stiffness of the tissue is after training is very hard versus the elite level athlete when they're at rest, they're soft, but when they start to move, it becomes hard. So it's a completely different type of stiffness.
Yeah.
So this is how we started to understand this is the correct way of training should never involve, changing the tissue stiffness to the opposite of what elite athletes are doing. Because our goal is to be like the elite level athlete. But if you're saying, okay, your tissue at the rest is already hardened because of the inflammation of weightlifting, you can't match what they're doing when they start to move. Because at rest, you're already different.
Yeah. Okay. So wait, so do you think that foot health and like ankle mobility, everything, that should be the foundation of all training for anyone? Like, I mean, like you're talking about, plantar fasciitis is very common for people.
Hmm.
So do you think like if people were to understand that the fascial lines start from the ground up, crisscrosses your arms all the way to the top of your head, like if people understand that the importance of fascia, like you're saying, it's supposed to contract and relax. Like that's what creates that stability for force. Do you think people should understand that more rather than just like say, oh, this is just an injury because I don't know. But I guess that's kind of what I'm envisioning. People to understand the importance of fascial um, training, especially like the athletes. So.
Right. I mean, the anatomy, the fascial anatomy, it's uniform across
Mhm.
all population, right? It's not like, okay, elite athlete has something special, but the fascia exists in all humans. So what is happening is with a lot of plantar fasciitis as the issue is it's really not about the inflammation. People think before they don't understand they thought it was a pain because of inflammation, but it's not because when we measure when the scientists measure the inflammation level, it's not nowhere as high. However, what they find out is that the fascia in the population that have fasciitis, plantar fasciitis, is thicker.
Hmm.
Guess what actually creates thicker fascia as well? Weightlifting.
What?
Weightlifting actually creates thicker fascia. So then
Okay.
you so very interestingly, you have to understand, okay, there is a relationship between the thickness of fascia. Why did it become thicker? Is it because it's not able to glide, or there's some adhesions that's happening, or there's it's adaptation to just too much force locally, right? So when we see these type of issues, and if we understand the fascial connection, we understand a little bit more because the plantar fascia should never be working on its own. So imagine if your plantar fascia cannot transmit the signal to the glutes, then it's
Hmm.
working on its own, right? But if you're able to establish a very fine connection from the foot to the glutes and it's very sensitive, which is something we see in top level athletes, because within 10 seconds they can do the elevated toe curls that we talk about, moving their toes, they can get there to the glutes within like 10 seconds. That means your glutes communication from the foot to the glutes is very optimal. It's very sensitive. So whatever your foot is sensing, your glutes is handling it.
Hmm.
But the people that usually have plantar fasciitis, this never happens. This is like poor. Also, what we find out is that when people are, even if they're a professional athlete or good level athlete, their fascial connection is okay because of the previous injury and poor biomechanics, they could interfere the plantar fascia as well. So, for example, they're using their foot and ankle incorrectly due to the shoe or due to a compensation pattern they have accumulated over the years because of different type of injuries. For example, ankle sprains, shin splints and things like that. Then they will run into the risk of having plantar fasciitis as well. And because your fascia, we have to understand it has a lot of pain receptors like the nociceptor, and it's integrating your nerves. So if the structure is disrupted, it's going to put a lot of pressure on the nerves.
Hmm.
And also, like people really need to look at the fascia as a very important tissue because you have other conditions. If you're a surgeon, you understand the importance of fascia, but they just don't have a way to train it, right? They just cut it. So for
Yeah.
example, your carpal tunnel syndrome.
Uh-huh.
Carpal tunnel syndrome in the wrist, the fascia puts on a lot of pressure to the nerves, and then the person's in constant pain, and then they move a little bit. Ouch, ouch. It's very painful. And guess what the surgeons are doing to solve that problem? They only cut the retinaculum fascia around the wrist and release the pressure, and then the problem solved. And then the person have to heal and get more room to this area, and hopefully that problem doesn't come back. That's all they're doing. So essentially what they're doing is they're just releasing the fascia.
Huh.
But that's a fascia issue. Now, let's think about this way. There another example, the compartment syndrome in the calves. The person will experience an increased pressure in the calves as they're moving, even the walking or running, right? And then the pressure builds up right in the calf area and doesn't go up. But this is also a issue with the fascia. Guess what the surgical intervention is? It's called fasciotomy. They're going to cut the fascia in the calf and release the pressure. Okay, so the mainstream that from the surgical point of view, medical point of view, they understand. Oh yeah, yeah, this is a fascia issue because all I have to do is change the fascia, is to cut the fascia, release the pressure, and the problem resolved. But ideally, we let's say take it one step further is to understand why this is actually occurring in the first place. Why does the pressure build up in the calf but not going up further, right? That's what the body's supposed. Your glutes actually also have compartments, and then the pressure should be building up in the glutes. But why does it stop in the calf? Now that's a fascia issue. So can we make the fascia better, right? So this is really the question that we try to explore when we started, doing the hyperofascial training. To understand, okay, there are many conditions that could occur on the fascia, but how do we resolve and solve these problems?
Okay. So if you could tell like people like what is Hyperarch your protocol of Hyperarch training? What is it in general sense?
General sense, it's very simply put, it's about tensional integrity and fascial engagement. So
Mm-hmm.
when a person develops, from a young age, from 6 to 18 years old, so your body is not just growing in height or size, your fascial system also is developing. This
Oh,
is a neurofascial development. But because we wear the shoe, as a society, is a construct of the society, right? We wear the shoe, we don't develop the foot the natural way.
yeah,
Okay. So if you don't develop the foot the natural way, you could introduce many factors and variables into this picture. You could develop your, for example, imbalances in your fascial connection from one foot to the other because you wear the shoe. You
yeah.
could suffer some sort of compensation issues after you, let's say, have an ankle sprain.
Mm-hmm.
But because of this unnaturalness of how we use our foot, we lose the ability to heal properly. Because remember, the fascia is not just a system that encourages us to move, because everything else is integrated by fascia. Your lymphatic system is
Yeah.
integrated by fascia.
Mm-hmm.
The fibroblast growth factors, they're all there's I think more than 50 different types of these growth factors. They are within the fascia. Within the fascia, you also have um, cells like macrophage and mast cells. They regulate inflammation. So
Mm-hmm.
there are so many different types of cells, and you have hyaluronic acid, which encourage the fascia to have glide and slide properly. And then you also have fasciicides. So this is also some cell that we recently discovered that helps the fascia form its structure and remain liquid enough so that the fascia can do its work. So all this is important. But if your fascial system never fully developed, the function of the fascia will be very poor because then it affects your healing. And then because of that, you can have nerve-related issues like varicose veins, you can
Mm-hmm.
have lymphatic issues. You can have hormone issues. You can have numerous different type of issues because your fascia system was never optimized or developed properly, right?
Mm-hmm.
But all this is being tossed aside because there's not enough emphasis or an awareness of this tissue because it has been ignored for a very long time.
Yep.
You look at the human body anatomy, you pick up any strength training book, has zero mention of fascia. It's just the muscle here. You have the quadriceps, you have the gluteus maximus. There is no fascia. However, the fascia is so important, it integrates everything together, right?
Yeah.
And this is very important to understand. So when we do hyperofascial training, we take a priority of fascia health. That
Okay.
has to be number one. We're not trying to make the muscle bigger because the mainstream, they're constantly arguing about how weightlifting is good, but they don't understand that when you do weightlifting, you cannot control if you're going to get microscopic tears or not. You will. And that's what causes DOMS, delayed onset muscle soreness, which lasts for 24 hours to 72 hours, right? And during those period of time, we also understand from from science that you have diminished performance because your muscle spindle will be damaged and you cannot calculate the force properly because you have delayed onset soreness because the microscopic tear doesn't just happen on the muscle, it also happens on the muscle spindle, happens on the Z disc of the fascia as well. So all this is occurring in the background. But if we look at how the elite natural athletes are built, they're built barefooted. They did not torn their muscles, and yet they're very powerful. And then the only possible plausible explanation is the myofibroblast, because the
Mm-hmm.
myofibroblast is contractile. It's a contractile cell. It can contract and relax, but at the same time, it can make the muscle stiffer.
Okay.
If you make the muscle stiffer and you can link everything together, you get power. You basically create a bowl that has a lot of stiffness. So in theory, this is how hyperarch fascia training works, is to stimulate the natural amount of mechano myofibroblast cells from the standard fibroblast cells. Because normally you wear the shoe, you don't get any mechanical tension.
Yeah.
You don't stimulate it. You get very little because the shoe protects everything.
Mm-hmm.
But if
Yep.
we start to train barefooted and we start to pay attention to what the toes are doing, to the foot are doing, and we build that mental map from the foot all the way to the brain, we can encourage the secretion and also the conversion of the myofibroblast cells, and then we can start to fascially engage everything. Now, we can this is also very interesting because when we talk about glutes dominant and core dominance also means that you can start to use because these areas have to have enough pressure.
Mm-hmm.
The muscle doesn't give you pressure. Again, remember previously I mentioned about a pathological condition called compartment syndrome, which means the pressure builds up in the fascia compartments. Now, if we understand that there is ability for the fascia to build up pressure in the calf, this can be used in obvious beneficial ways because if the pressure builds up correctly in your core, guess what? You can you can move very well because your spine will be solid because of the pressure protecting you. Same thing with your glutes because your glutes also have compartments.
Mm-hmm.
The glutes have compartments and you also need to be pressurized properly in order for you to be glutes dominant. That means you start moving, your foot touching the ground, a few steps, you start moving a little faster. The fascia will then send signals to the glutes and your glutes start to be solid. And that's what we see in high level athlete, division one and higher. But average people that, wear these cushion shoes that they're running, they have joint issues, they have arthritis, they have fascial imbalance never heal. They have sciatica. Again, it's previously people think, oh, you're sciatica because you have the piriformis muscle that becomes shortened, but the muscle doesn't shorten by its on its own.
Mm-hmm.
It's being integrated by the fascia. So now we understand the correct explanation should be that your fascia environment, for example, you change from a liquid state to a less viscous state. It's more solid, and then you put pressure on the nerves and that will affect your muscle contraction. Even the wrapping angle of the fascia on the muscle matters greatly because there is a research that was done from Brown University um, that demonstrated that how the fascia wraps around things. So if the orientation is off by a few degrees or by, for example, a 45 versus 70 degrees, the
Mm-hmm.
contraction of the muscle is it's exactly opposite. So
Yeah.
all this is not being talked about enough because you see the people doing sports today, they're still stuck in chronic pain. A lot of the high level athletes are taking painkillers. They don't really have a solution. But
Mm-hmm.
what we want to do is change all that.
Yeah. And that's awesome. So I guess to close off, that's definitely something I think a lot of people should look into, doing what you're doing and to reach out to you because obviously if you want to be a top athlete, professional, they should learn about the fascia system and how it integrates with athletic performance. So appreciate you for sharing that with me today.
Great. So where are you located?
Baltimore, Maryland.
Baltimore, Maryland. Okay, great. So I mean, uh, I worked with some athlete in that area before, and I can definitely tell them to visit you.
Okay, perfect. Yeah, definitely. Vice versa. I mean, I think a lot of people should learn more about, a lot of the people that you're working with. I know they're on the same, realm as us, is trying to integrate fascia into people and get more people to learn about the fascia system and how important it is. So I appreciate your knowledge, the work you're doing, because more people should learn. More people should uncover these truths that modern medical system they don't understand the importance of fascia. They do disregard. So it's important the work that you're doing, the work that I'm doing, to bring fascia awareness to people. So thank you so much.
Great. Thank you, Ian.
Yes, sir.